So we're off to the next in our long series and study of circles. In this circle discussion, we're going to go in and look at angle measures and their segment lengths. So as we're moving forward, the standards that we're working on today proves the properties of angles for a quadrilateral inscribed in a circle and identifies and describes the relationship among inscribed angles, radii, and chords. For the first theorem that we have to write down today, you want to look at two chords which intersect inside of a circle. So you have essentially two chords that intersect, and those are happening inside. Both of those chords then intersect the outside of the circle, right, or the circumference of the circle, and they make arc measures, right? So those are our arc measures right there. So the measure of an angle formed by two lines that intersect inside of a circle is half the sum of the measures of the intercepted arcs. So you can see here angle X intercepts the arc from A to C, and then this other angle intercepts the arc from D to G. So in order to find the measure of angle X, what I would do is add together the measure of ABC as an arc and DFG as an arc. So when I add those two together and then divide it by 2, I'm essentially taking the average measurement of those two. That will give me the measure of this angle. So in the next theorem, the measure of an angle is formed by two lines that intersect outside of a circle. And what we find out there is that the length of that, or the size of that angle, is half the difference of the measures of the intercepted arcs. So if we look again here, we can see this arc is intercepted from A to C and from C to B. So in order to calculate the measure of this angle 1, we would take the measure of the arc BC and subtract the measure of the arc AC, and then divide that number in half. So the measure of BC minus the measure of AC, and then divided by 2 or multiplied in half. And that will give us the measure of angle 1. Another way to look at that kind of depends on which type of lines you have intersecting your circle. You could have two tangents that intersect your circle, and then again, to find the measure of this angle, you would take the measure of arc B, subtract the measure of arc A, and divide it by 2. So you can see here, B minus A divided by 2. If you have a tangent line and then a secant which would cut through the circle, you would do the same thing. You would take the measure of that arc B, subtract the measure of arc A, and divide by 2 to get the angle measure. And then here's kind of a worked example for you. If you have two secants which are both cutting through the circle, you would take the measure of that arc B minus the measure of arc A, divide it in half, and then you would end up with the measure of the angle here that sits outside of the circle. So this example, B was 90, A was 20, so they took 90 minus 20, got 70, divided it in half, and then we can see that the angle that's left here on the outside is 35 degrees. Now, as we're working through on this one, I'm going to kind of move out of the way here a little. There's one theorem here, and then there's kind of 3 applications of it that you want to pay special attention to, especially because each of them has a different formula for calculating. For a given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and the circle. So what this really means is that if we have a circle that has two chords inside of it, the product of the two parts of the chord will be equal to the product of the two parts of the other chord. So in this one, we can see our red line and then also our blue line. This tells us that the product of A times B will be equal to the product of C times D. Now this is true when both of the chords, when we have two chords that are inside of a circle. The next one talks about if you have two secants, right? So remember, when you have two secants, they come outside of the circle and intersect at a point here. The product of the secants and their outer segments are equal. So if you notice here, I'm going to take the line WX, and I'm going to multiply that by just the part that's outside, which is W. So the whole line times the part, and that will be equal to the whole line times the part of the other secant. Then lastly, our third one that we want to talk about involves a tangent and a secant for a circle, and you'll notice that the product of a secant and its outer segment equals the square of the tangent. So we can see I have a tangent here. So the length of this tangent squared will be equal to the length of the whole secant times its outer part. So t squared will be equal to y plus c, the whole, times the part. Okay, here's the last little Harry Potter math joke for you guys. And on the second video, I'll work out some problems that deal with these theorems that we looked at, and then make sure that you get in and give them a hand in your textbook work or your worksheets. And if you need any help at all, please come and see me or Miss P, who I'm so happy to have back.